Top of the day, this is Mark Evanko, Principal, CEO of BRUNS-PAK. Across the US and the world, power is the #1 consideration or impediment associated with deploying AI. This far exceeds compute hardware delivery and cooling solutions. We are observing there are 4 major activities associated with the electrical utility constraints. On-site power generation. People are now looking to solve the power utility issue if it's delayed for 4 or 5 years by the utility company. This includes emergency generators, turbines, fuel cells, battery systems. AI-driven load forecasting is critical. Specifically, the AI workloads can be programmed so you don't have a specific peak, but you can actually manage that peak into a constant load. Permitting delays. Sometimes 18 to 36 months in power-constrained regions, and in some markets up to 5 years. We recently did a study in Canada. It reflected the utility company bringing AI power 12 to 14 years. The impacts are real and accelerating. 44% of developers face utility wait times longer than 4 years, forcing relocations or in some cases, full project cancellation. 8.7 gigawatt of on-site generation capacity was announced globally in 2024 by operators aiming to bypass grid constraints. This is critical. Projects are being redirected to less congested but more expensive regions, simply to gain access to power, even if it means trade-offs in latency, network topology, or staffing. The power utility readiness has been overlooked for many, many years. Those days are done. This requires early interface with the local utility companies to see whether in fact a site is even viable for the short and long term after the requirements have been done. BRUNS-PAK has a method to develop an IT readiness study for these AI HPC deployments that is total cost of ownership versus best practice versus risk. We're currently working with many developers to investigate the feasibility upfront about, is this site even viable? We'd certainly like to help you along your mission. Thank you and take care.